Researchers at the University of Helsinki in Finland have developed a chewing robot to study the tie between the tooth wear and the dietary patterns of animals. Their shiny stained steel chewing machine with 3D printed parts can now show how the paleodiet of the animals affected their tooth wear rate and potentially their lifespan. I'm Lučka Bibic, and I spoke to researcher Alexis Karme.
So we actually built a chewing machine with real horse teeth and chew different foods like grass or grass with added sand. This chewing machine chews for about 2.5 million times, 206 times per minute, about a workday for a tooth pair.
Quite speedy then. So the chewing machine keeps chewing and you keep measuring the wear of the teeth. But back to the basics. Why does our tooth enamel wear away?
The hard tissues in teeth are enamel, dentine, and cementum. Enamel is the most mineralized and hardest tissue, and with us humans, the topmost layer. It is very durable but also brittle, so if you bite on a hard particle, you might fracture it and lose a chunk of it. Most of the food components are not as hard as the teeth, but there are small particles like silica in plants or dust and grit mixed in the food by wind or soil. This said, everything actually wears teeth, but with very different rates, this being one of the key findings in our research.
Does this faster chewing robot come with some tacky details? How does it look like? Does it have an unfortunate look, or maybe is it loud and smelly?
It was a very noisy lab for several months. The machine is actually almost fully made out of stainless steel. There are a couple of nylon parts and a couple of 3D printed parts. But it's shiny that is totally submerged in food, and it's doing all the chewing inside there. And it's chewing over 260 times per minute, so it's actually quite fast and noisy.
Because I was eager to find out more how awful does it sound, I asked Alexis to record the chewing language of his robot.
The chewing machine is making the bass beat or bass beat, so it's kind of having like a band in your lab.
Well, seems like you have some rock and roll fun in the lab then.
Yeah.
But I guess that when it comes to measuring the tooth wear, the science behind is a bit less fun, or not?
So what we did, we looked at microscopic wear features on tooth surfaces after the chewing, and also how much of the tooth was lost during the experiment. And this we did with the microscopic features and by 3D CT scanning. And with this we could compare the differences between different diets and how the wear patterns were different, and also how the wear rate differed.
People have been working on extinct species for quite some time. Can a chewing machine help to tease out some of the evolutionary secrets that are still hidden?
One of the key questions is actually how the animals lived. One really crucial part of that living is actually eating. This is something we really want to know, that what different foods and other factors like dust or sand will do to the teeth. Because from the teeth, we can know the diets of the animals, and from that we can know the environments and the climates that the animals lived in.
Well, definitely some food for thought. What were the conclusions then?
We found out that everything does wear teeth, but that the microscopic patterns don't always differ that much with different diets. But wear rates, on the other hand, really do. But if you eat soft foods like, let's say, tree leaves, with horse teeth, you would live up to 600 years if it would be only the teeth that determine it.
This was Alexis Karme from University of Helsinki, and his research was published in the Royal Society Interface.